Now that we've practiced all of the skills that we need, particularly finding the inverse, I want to show you the second method that we can use to solve a system of equations. So we've talked about Gaussian and Gauss-Jordan. I just clumped that in as one method because they're really similar. The second method is matrix equations. So let's look at how we write a matrix equation first. A matrix equation is always in this form. A is the coefficient matrix. Coefficients are the numbers in front of x and y. X is my variable matrix, so just x and y. And B is my constants matrix. So let's take a look at how I would write this system in a matrix equation, and then we'll talk about how to solve it. So just as we did with Gaussian and Gauss-Jordan, these guys both need to be in the proper format, and this first one already is, but the second one I would have to write as negative 4x plus y equals 8. So to write this as a matrix equation, I'm going to write 2 and negative 3, negative 4, 1, which is all of the coefficients. And then I'm going to put times, and then xy goes right here. And then I'm going to put equals, and then I'm going to put my answers 6, 8. That is how we write a matrix equation. So let's take a look at how the purpose here, which is of course to solve a system of equations using the matrix equation method. So typically there are just several steps. The first step is to write the equation. So I have to write the matrix equation. And the matrix equation we just learned how to do. 3, negative 5, 2, 6 times xy equals 91, negative 14. A lot of people skip that step and you lose points on your assessment. So don't do it. Make sure you write the matrix equation first. Step 2, I'm going to find the inverse of A. Now again, we just learned how to do that. I think it's easiest to use that little formula that says, let's take 1 over 3 times 6, which is 18, minus 2 times negative 5, which is negative 10. And I'm going to multiply that by the 3 and the 6 switch places, the 5 and the negative 5 and the 2 switch signs. So I'm taking 1 over 28 times that matrix, which gives me a nice 6 over 28, which I'll reduce to 3 over 14. 5 over 28, which doesn't reduce. Negative 2 over 28, which is negative 1 over 14. And 3 over 28. Okay, so that's step 2. We write our matrix equation, we find our inverse, and then we come to this. This one says, if I take A inverse A, well, we know A inverse A, what's that going to do? That's going to just give me the identity matrix. And then I'm going to take A inverse times B, and when I do that, B is this guy. When I do that, the resulting solution will be the solution to my system. So here's what that's going to look like. I'm going to multiply A inverse on each side. So that means I've got 3/14, 5 over 28, negative 1/14, 3/28. I'm essentially going back up here now to my original matrix equation, times 3, negative 5 to 6, times xy. That does not look like an xy. Woo, there we go, a little better. And then on the other side, I'm going to take 3/14, 5/28, negative 1/14, 3/28, and multiply it by 91, negative 14. Now on this side, when I multiply, essentially what's going to happen is I'm going to get 1, 0, 0, 1. And for the sake of time, I'm not going to multiply that out. But that is what happens. So if you're doing this on a test or something, I'd probably, make sure that you get 1, 0, 0, 1, even if you don't show that work, because most of that work's done in your head anyway. But you would want to make sure that your inverse is correct, because if your inverse is wrong, then your solution's going to be wrong. So that's what happens when I multiply these. I'll still have times xy, and so now it should look kind of like it did when we were looking at Gaussian and Gauss-Jordan, because essentially I'm saying 1x equals, and then I'm going to have some answer, and then 1y equals, and I'm going to have some answer. So let's work on finding the answer. I'm going to take 3/14. I'm going to do this over here just so I have more room. 3 over 14, 5 over 28, negative 1 over 14, 3 over 28. Oh, I wrote the wrong ones. Sorry about that. I actually wanted to write the 91/14, because then I'm going to take my first row and write it here. 3/14, 5/28. So 3/14 times 91, and I'm just going to leave it in fraction form, so I'm going to take 3 times 91, and that's 273 over 14 plus 5 over 28 times negative 14, so 5 times negative 14 is 70 over 28. I'm going to cut that in half just so I can add it to the 14. So negative 70 over 28 is the same as negative 35 over 14. And then I'm going to do the same thing with the other guy, which is negative 1/14 and 3/28. And I'm going to get negative 91/14 and negative 21/14 if I reduce from the 28 that I would have on the bottom. Cool. So now let's see what happens. 273 plus negative 35 is 238 divided by 14, which is 17. And negative 91 plus negative 21 is negative 112 divided by 14 is negative 8. And so my solution to the system is 17, negative 8 as an ordered pair, positive 17, negative 8. One more practice for you to try to make sure you understand matrix equations. Step 1, remember I'm just going to write the matrix equation. 4, negative 1, 3, 4, xy, and then my constants, 11, 13. Step 2, I'm finding the inverse, which is 1 over 16 minus negative 3. So again, that's the downfall of this method, is just a ton of fractions. The 4 and 4 switch places. The negative 1 turns into a positive 1, the positive 3 into a negative 3. And so I've got 1 over 19 times 4, 1, negative 3, 4. And that gives me a crazy inverse matrix, which is 4/19, 1/19, negative 3/19, 4/19. Again, what I'm going to do then is I'm going to multiply the inverse by each side. And just for the sake of room, and it's fine with me if you do this on your assessment, just make sure that you understand why we're able to do this. Instead of rewriting this times this, I'm just always going to know that that's going to give me 1001. So I'm just going to cheat and go straight to 1001 times xy. And then here I'm actually going to show what I'm going to multiply. 1419, negative 319, 119, 419. I'm multiplying that by the existing 1113, and then I'm just going to find my solution. My solution, oh, I'm going to move this over, give me a little bit of room to show my work. So 4/19, 119, that will give me 44/19 plus 13/19. And then if I replace that with the next row, negative 3/19, 4/19, that would give me negative 33/19 and 52/19. And then I'm just going to add 44 and 13 divided by 19 gives me 3. And negative 33 plus 52 gives me 19. Divided by 19 is 1. So my solution is 3, 1.